Okay, we're going to start talking about solving systems using elimination. And one thing that we need to look at when we talk about elimination is the definition and the description of the elimination method. So we have solved by graphing, which is really easy, especially if it's in slope-intercept form, but not always feasible, especially if you wind up with a lot of decimals. Or we've also used the substitution method, which is also very easy. If you have a variable that is by itself with a coefficient of 1, then it makes the substitution method very simple. Elimination method is a great method when you have standard form. Now remember, standard form is ax plus by equals c. So standard form is a great way to use, or elimination method is a great way to use to solve systems with standard form. So when we talk about the elimination method, this is the definition that we have. A method for solving a system of linear equations by adding or subtracting the equations to eliminate a variable. Eliminate means we just completely get rid of that variable. We will need that variable later, but to initially start a problem, for example, this one here, I have x's and y's, and it's very difficult to get an answer when you have two variables. So if you eliminate one of them, then it makes it a lot easier to solve it. So what they've done here is they are going to eliminate the y's. Now the reason we're eliminating the y value is because the coefficient is the same. Now the positive or the negative, the plus or the minus, not really interested in that initially when you're trying to figure out what variable to eliminate. What you want to look for is simply the coefficient. So if you see this x has a 3 and this x has a 2, adding and subtracting will not eliminate that x. If I add 3 and 2, I get 5x, which increases the amount of x's I have. And if I subtract these, 3x minus 2x, I would get 1x. So I'm still left with that x value. So the y's here are the ones that we are eliminating. Now, the y values, one's a positive and one's a negative. So again, when you're doing this, you have to think about, if I cover up these x's and I pretend like they're not here, and I have a positive 1 and a negative 1, what would I do to eliminate them? I want 0. I want nothing left. So you have to think, am I going to add 1 plus negative 1, or am I going to subtract 1 and negative 1? And that's usually the hardest part of elimination method, is deciding when to use addition and subtraction because of negatives. So you got to be very careful with your negatives. In this example, they add the equations, because if you take a positive 1 plus, think about putting a big plus sign out here, a positive 1 plus a negative 1, you're going to wind up with 0. You're not going to have any y's left over. So what that does for you is it eliminates, I'm going to cover this up with my cursor here, you have 5x equals 20. And so that's an easy equation to solve. You divide both sides by 5, and you get x is 4. So that's the elimination method. We eliminated the y, and we were just left with the x, and it made it much easier to solve that problem. So now we have the x value, which is 4. Now we're not finished. What you have to do next is pick an equation. It doesn't matter which one you pick, but substitute the 4 in for x. Now they chose the second equation, and they put 4 in place of the x value. So instead of 2x minus y equals 1, we now have 2 times 4 minus y equals 1. And then they simply just solved that for y. So 2 times 4 is 8. You're going to have to subtract. This is a positive 8. Remember, we're worried about what's out front, not what's in front of the y. So this is a positive 8. So you would subtract 8 from both sides. And then you would have to divide both sides by negative 1. And you will get 7. So the solution to this system, even though they don't have it written out, the solution is 4, 7. That's your coordinates. So eliminating a variable, that's what we're talking about here. So let's look at this example. 2x plus 5y equals 17. That's our first equation. And the second equation is 6x minus 5y equals negative 9. So look for the variable that has the same coefficient in the first one and the second equation. And if you notice, the x's have a 2 and a 6. Those are not the same, but my y values both have 5s. Now one's a positive and one's a negative, not a big deal, as long as they have the exact same coefficient. Now you do have to ask yourself, am I going to add these two equations together, or will I subtract in order to eliminate the y's? So if you wrote it out, if you wrote positive 5 and negative 5 on your paper, would you put a plus sign between those, or would you put a subtraction sign between them? If you're not sure, use your calculator. Type in your calculator 5 plus negative 5, and then type in 5 minus negative 5. And you will see you'll get two totally different answers. 5 plus negative 5 gives you 0. So we are going to add. 5 minus negative 5, if you were to try to subtract, you're going to get 10. Because remember, two negatives side by side turns into a positive. So it changes your signs altogether. So we are going to add. So we're going to look at the solution that they have here. This is their plan. Like I said, we are adding. So since the sum of the coefficients of y is 0, add the equations. And so that's what we just discussed. So 2x plus 6x gives me 8x. Of course, adding those gives us the 0 that we want. And then here, when you add 17 plus negative 9, you get 8. Now remember, you're adding. It's kind of elementary school, adding vertically. You're just adding each one of those terms together. So you get 8x equals 8. Now, you solve that and you get x equals 1. Now, you're not finished, because after you found what x equals, then you've got to go back, pick one of your equations. It doesn't matter. This example, they did pick the first equation, but you could pick the second one if you wanted to. But plug in that 1 in place of x, and that's what they did here. Put 1 in place of x. 2 times 1 is 2. We still have our 5y. Subtract your 2 from both sides, and then divide both sides by 5. You're going to get y equals 3. So that means your solution to this system is 1, 3. So adding or subtracting, you've got to determine which one. That's usually the hardest part. And then once you've picked the correct operation, then you just eliminate your variables and solve. All right, so now it's your turn. I want you to solve this system of equations, determine which variable you need to eliminate, determine if you should add or subtract, and then actually go ahead and solve this system and give me the intersection. Now, I am going to show you some answer choices that you can pick from. So clearly, if your choice is not up there, if your answer is not up there, you need to go back and double check your problem. Maybe you used addition instead of subtraction. Maybe you used subtraction instead of addition. So you need to be real careful with that. Pause the video and try this problem. And hopefully you've worked this problem out on your own, and the correct answer is A, 2, 7. Here's your solution page, so you could go ahead and pause the video when that page comes up and just double check to see if what maybe mistakes you made when you were trying to eliminate the variable and solve this system.
In this problem, you will solve a system by subtracting equations. The theater club sells a total of 101 tickets to its first play. A student ticket costs $1. An adult ticket costs $2.50. Total ticket sales are $164. How many student tickets are sold? Your choices are A, 25, B, 42, C, 59, and D, 76. Define the variables. Let A equal the number of adult tickets. Let S equal the number of student tickets. What are the two equations in the system? One equation will represent the total number of tickets. The other equation will represent the total ticket sales. Now write the two equations. The total number of tickets is represented by the number of adult tickets plus the number of student tickets, which equals the total tickets sold, 101 tickets. The total ticket sales is represented by the cost of an adult ticket, $2.50, times the number of adult tickets, plus the cost of a student ticket, $1, times the number of student tickets. which equals the total ticket sales, $164. Step 1. Eliminate one variable. How is this problem similar to problem 1, where you added the equations to eliminate a variable? In each problem, you are looking for coefficients of one variable that are either the same or opposites. Here, the coefficients of s are the same, so eliminate s. Since the difference of the coefficients of s is 0, eliminate s. Subtract the equations. Solve for a. So a equals 42. Step 2. Solve for the eliminated variable. Use either equation. You can use the first equation. Substitute 42 for a. Solve for s. So s equals 59. There were 59 student tickets sold. The correct answer is C. 42 is close to 40, and 59 is close to 60. The total number of tickets is about 40 plus 60, which equals 100, which is close to 101. The total sales are about $2.50 times 40 plus $60, which equals $160, which is close to $164. So the solution is reasonable. Now it's your turn.
Okay, so you've got an example just like the last word problem. You're going to set it up exactly the same way. You've got washing 2 cars and 3 trucks takes you 130 minutes. Washing 2 cars and 5 trucks takes you 190 minutes. So you've got your AX plus BY equals C. So that's your first equation. Then you've got your second equation, AX plus BY equals C. So they've given you the A, B, and C for standard form for each of your equations. So go ahead and pause this video. I'm going to show you some answer choices, but pause the video and try to work this one out using the elimination method. See, once you've solved your equation, hopefully your answer choices are the ones, is one of those listed there for car and truck. Now, hopefully you've worked this one out and hopefully you got it correct, but here is the correct answer. The car will take you 20 minutes and a truck will take you 30 minutes. And for your solution page so that you can see maybe what you missed, this is them writing out the 2 equations. X is your minutes per car and Y was the minutes per truck. Now we're going to eliminate one of the variables, and for this problem, eliminating the 2x was the easiest. And so you can see down through there how they solved that system of equations.